Hello, everyone. Welcome to another installment of our Applied Building Science webinar. My name is Joey Starr. If this is your first time, welcome. Before we get started, and as everyone else kind of trickles in, we do like to go over a few housekeeping things. So as you probably heard from the announcement, everyone is in listen-only mode, so you cannot speak with us. But you can communicate with us. Use the Q&A feature. I will be monitoring that throughout the presentation. A few of you have already chimed in, so go ahead and shoot any questions, comments, concerns you have through that Q&A feature. You find that by clicking on this little orange arrow that's in the top right of your screen. You should be able to see that there. You can see the audio as well. And that's where you can change your settings if you're having trouble hearing us or something like that. You can also find the handouts feature. We've got the copy of today's slides posted there already. So it's usually the most frequently asked question is how can you get the slides? So they're already there. No need to ask. And keep in mind, as always, this webinar is for a general audience. We have HERS raters, weatherization folks, everyone else, homeowners. Just how did we phrase it the other day, Mike, on that webinar? General energy enthusiasts. So keep that in mind. That you know, we've got people from all backgrounds and everything here. So some of this may be over your head, some may not, some of it may not be. We promise you'll probably learn something by the end of it. And then keep the feedback coming. We are going to be sending out a full-fledged survey at the end of this webinar, either today or tomorrow, to get your feedback on kind of the webinar series as a whole. So please look out for that email from Ali. So without further ado, you've heard him giggling in the background. We've got Mike Barsick here. Mike, if you want to introduce yourself.
Yeah. Hi, everybody. Thanks for joining us, and you know, shout out to Ali and Joey. Thanks for helping to put this all together. And these have been a lot of fun for us, and I think this one is going to be kind of neat because it's a chance to talk about just some, you know, larger issues of designing high performance homes. So it could go in a lot of different directions. You could spend a day or two on any one aspect of it, but we're just going to sort of say from a higher level, what would you do? So I think that's going to be fun. Joey, anything you want to add?
Yeah, and you'll hear us. I am actually seeing quite a few new folks on this webinar. So if you haven't been around, we've done about 12 of these, and this one in particular kind of encompasses all of the previous ones, or most of them anyway. So frequently you'll hear us refer to previous webinars, and if you missed them, that's okay, because we have them available for free on our LMS system. And I believe some of them are posted on YouTube as well. So you'll hear us talk about that, and I'll tell you how to get to those.
Yeah, and we also, the last one we did was on load calculations. That's going to get posted along with this one fairly soon. So let's see. If you haven't joined us, usually there's some funny picture that pops up. Joey, I was thinking about one of my favorite movies, which was Young Frankenstein. So that's me on the left, and then I don't know, I was playing around with your hair, but this is what I came up with. Yeah. So it looks good, doesn't it?
It's not far off, that's for sure.
Uh-oh, did you take the view away? Oh, yeah, oh yeah, actually, that's, if you could put the electric streak going up in white, that would be really good. Yeah, I like it. That looks good. Thank you. So anyway, having said that, welcome to those who've joined us. Our organization, Southface. Joey, you want to kind of give them the spiel here real quick?
Yeah, so we are involved in the built environment, trying to increase efficiency and health throughout, whether it's, you know, your workspace, your home, or anywhere in between. And that's what we do. Typically, we do a lot of these trainings in person. But that's been a little bit difficult lately. So we've tried to kind of keep people engaged through this webinar series, which has been a lot of fun. and hopefully some of you have enjoyed it. So please, check out our website. We've got a lot of great resources there. We don't really have any events or anything coming. Oh, actually, we do have some
Right, I was
events
gonna
coming
say,
up.
yeah.
Yeah, we have the solstice, I believe, is coming up, even though the solstice is long.
How can you have the
Or
solstice in August?
we're
That
basically
can't.
in between. But anyway,
That
we're
make it
having
the
some events. Go
equinox.
to our website. Please support us in whichever way you can, is the long
Yeah,
and short of it.
that's pretty funny. I was going to mention too that we are working to kind of pivot and figure out how to teach certain classes, and a combination of online and also with some other content. So one that's coming up at the end of August 31st through the first couple of days of September is we're going to teach the DET verifier class. We still have a few slots open in that. If you're interested, it's mostly going to be remote. And if you own your own equipment, you potentially don't even have to come in. We'll remote proctor it. But if you don't have your own equipment, we've figured out a way to, I think, safely proctor individuals one at a time to come in and actually do the testing and prove to us you can do it. And then everything else is going to be Zoom and online electronics. So that class is coming up in about 2 weeks. And also in October, we're going to teach the home energy rating system class. So if you want to be a full-on HERS rater, we're hammering out the details. I think we've got it more or less figured out how that's going to look. And that'll be a series of, it might be like 2 weeks of, half day Zoom classes, that kind of thing. And then obviously a lot of practicing on your own and stuff up front. So we got a plan for that. Our website necessarily reflects that, but if you're interested in either of those classes, please sign up so we can, save us a spot for you. All right, enough of that. We're going to do a quick poll here. We're assuming that you're one of these entities over here, a designer, energy enthusiast. I really like that. So if you would, Joey, you want to pop up your poll there real quick? And we have a question.
Yeah, so we always like to kind of gauge who all is here. I think after 10 of these, we have a pretty good idea. But if you're not one of the thing, we'll go back to that slide in a minute. But if you're not represented by any of those answers, you can always chat me a message. And really, we kind of wanted to get a good idea. It's like almost completely evenly split, which is
of what? I can't see the poll, so you have to
yeah.
tell
I'm
me.
I'm gonna give everyone just a minute or two
So
longer
what is the
to.
poll? What's the poll question? Because I can't even see it.
Oh, sorry. How many of these webinars have you attended?
Okay. So what are the choices?
So let's see here.
I don't
That's
know. I think we should give a special prize if anybody has attended, 10
well,
out of 12.
almost a quarter say they've been here for 10 plus. So we'll
Wow.
check
Wow.
we'll check our
I can't
rolls
I
and
can't
we'll
afford I can't afford that many
trophies, medals, whatever we do. Yeah.
gift cards to the growler store or whatever. Yeah, so sorry about that. I better watch out what I'm promising here. But no, that's
Yeah.
great. And again, we really do appreciate your feedback and your attendance. So you ready to move on?
Yes.
Sorry, because I can't see it, so you'll have to just tell me. But all right, I'm gonna take it back
Yeah. Hey,
here.
your screen showing now.
Okay, good. Thank you. So again, welcome. Always want to make a pitch for there's always a lot of good information on our website, but specifically, we recently came out with these field guides and helping explain the energy codes with pictures. And obviously, a high performance home is gonna meet / exceed the energy code. So that goes without saying. And I think we've made a pitch for this in most of our trainings about why this stuff is so important and how to apply it to real world situations and understanding. Again, it's about the flow of heat, air, and moisture, and that houses are systems and they're made up of components, and trying to integrate good design into all this is ultimately going to lead to a high performance place for people to live in. And I think people have probably in the last 6 months had a renewed interest in what it's like to be in their home a lot and what that impact is on them. And I do think that coming out of this, it'll be interesting to see what changes home design. I think you're definitely going to see more focus on use of space for like home office or homeschooling, probably enhanced pantry or food storage or toilet paper storage. I think that's all in the works, but it is an interesting sort of thing that we're learning about how to make our home good. So here's what we really want to cover today. And I'm just going to say my goal is to get mainly through the first bullet and probably get through at least the first 3 bullets. And if we have time, we'll talk about the HERS industry some at the end. I sort of padded some content there. So I really want to just focus on just kind of have a conversation with you, Joey, and see if people have comments or questions. So when I high level approach this, I kind of go, what first of all, people have asked me, should I do? I want to design a high performance home. What should I do? And I'm like, okay, well, first of all, we're gonna, have an understanding of the concepts, the physics, and we're gonna let that be our guide. So heat, air, moisture. We're gonna specifically focus on doing a really good shell or an enclosure, and that's gonna be structurally sound. It's gonna be, well insulated and airtight. It's gonna be durable from a moisture standpoint. All that good stuff, and hopefully also constructed out of materials that are environmentally, positive in their attributes, or at least try to minimize the negatives. We don't want to put something in that either is going to make us sick or poisoned a bunch of people in its manufacture or whatever else. So just trying to kind of go a little deeper is part of our nudge on that topic. I decided to go ahead and spell out air distribution because I felt like even homes with sort of different mechanical systems, there's always going to be, at the very least, a ventilation system that is ducted. And just understanding, usually in this country, we're still building a lot of ducted mechanical systems, and how do we do those right? And we've certainly spent some time on these. And then in terms of plug loads, kind of making good decisions about equipment and not just mechanical stuff, but other stuff that plugs in, since those loads tend to be kind of more dominating in newer buildings. As we make the shell more efficient and the heating and cooling equipment more efficient, we're starting to see more and more, the plug loads become the tail wagging the dog. And then by all means, in this day and age, we need to be thinking renewables. And if we're not going to actually install them, we want to make it easy to do that. So that's a high level push on this. And I would say try not to get too obsessed with a given technology. It's really not about an individual technology. It's about thinking in a systems mindset and putting things together in a well thought out, integrated manner. So, all right, Joey, I'm off my soapbox. So I had to do this a couple of years ago with my colleague Burke at the time, and we were presenting to a group of architects, and I thought, well, let's just, I must have watched David Letterman or something. Let's make a top 10 list of things that you should pay attention to. And so this is what we came up with, and I'm sure there's other things, but ultimately it's a starting point. So some are more obvious than others, and like you said, Joey, I bet we've done a webinar on just about every one of these, right?
Mm-hmm.
Maybe not the last couple or so, but most of these. What have we not done it on? I don't know. So, and also I'm going to say there's both design and then there's technology, and we want to sort of use them both intelligently. We don't want to go, try to rely on technology to offset a poor design. And likewise, let's take advantage of what technology can offer us to make a good design. So, all right, Joey, number one, pay attention to the sun. What's the rule here?
You generally want glazing on the north and the south and minimize it on the east and the west. That really allows you to take advantage of these overhangs. This is actually our building at Southface, built in 1996. So even though it's 25 years ago, the sun hasn't changed a whole lot. So we were able to take advantage of long-lasting design decisions. So you can actually see, You can actually see the first picture, the one with the shading, is taken just basically a few weeks ago at the summer solstice,
At high
July
noon.
21st, and at high noon. So the sun is at its peak, and you can see our overhangs, which aren't very wide. They're not they don't stick out. They don't look silly. They're just normal overhangs. They're blocking quite a bit of the sun. And then in the winter solstice, when the sun, and we're actually gaining all that solar energy that we need to kind of heat up the building in the winter, which is especially important in winter climates. They really have to basically capture that sun. We do it more as a convenience, and it takes a little bit off of our heating loads for sure.
Yeah, I realized I didn't line up that picture very well. That bothers me, so I'm gonna fix that. But anyway,
Okay.
the big message is there. Now that's a little better. The big message, though, the big takeaway is that we're orienting our glazing, trying to be intelligent about it, and Southface glazing, that it's a passive solar term that to really load up on the southern exposure. And then, of course, today we have double pane low E windows, which somewhat put passive solar kind of on the back burner, but it doesn't change the fact that a west-facing window, even though it's low E, is still going to gain a lot more than a north-facing window. Or so if you've got a corner bedroom and you're looking at where do I put my windows, try to minimize what's on the west. You can still have windows, but try to make them small and try to maximize on the north and south. And the reason we say north is because we are a mixed climate with significant air conditioning. In Colorado, it's all about the south and none on the
Mhm.
north. So it's a little different strategy. So pay attention to where you are. In terms of window technology, the standard window today is really a pretty good window. It's at least 2 panes of glass. It's got a low emissivity coating on one of the inside panes of one of the pieces of glass. And the frame is made out of a material that's not that conductive. So we've gotten away from metal frame windows. Wood, vinyl, extruded fiberglass. Wood is certainly a natural material, but I would say of the three, probably the best is extruded fiberglass frame because it has all the benefits of wood and vinyl without all some of the detriments of them. It's basically fiberglass is glass, and it's a little bit energy intensive to make it, but it doesn't have the toxicity of manufacture that vinyl does. And wood, of course, is a natural product, but it has a risk of durability, not if it's installed right and maintained. But the other thing I like it's a little hard to see, are the sun tubes. You can kind of see it a little better there. Solar tubes that let natural light into an interior space. They, to me, offer, you're giving up 1 square foot as opposed to a skylight, which, might give up 6 or 8 or 10 or 12 square feet. So less loss associated with that. And try to, again, don't just put windows to load up on glass. A lot of custom homes tend to do that, but try to use it intelligently. And the only question that comes up is this passive solar term is, okay, should I use clear windows on the south facade so I'll catch more in the winter during the daytime? And my answer is no. My answer is to use double pane low E all around the house. And the argument would be you'll catch a little bit less when the sun is out in the daytime, but you'll lose less at nighttime when it's cold out and your heat transfer is going the opposite direction. And Atlanta also has a fair amount of cloudy winter days. So, it's really better to put low E everywhere. If you really want to go nuts, you can buy windows for just the south that you can buy windows that are double pane low E, but they're high solar heat gain. So in the summer, you're not going to suffer much because they're shaded or they're not getting much direct solar gain because of the angle. And in the winter, you can gain more, but they're still low E, which helps their conduction. Okay, probably spent too much time on that, but fun to talk about. Joey, this one we did a whole webinar on, right?
Yes, we definitely did. And of course, a few of you probably were on that one. If not, please go to our website and check it out. It was a lot of fun. We were definitely on our soapbox for quite a bit of that time, but one of the main things that we talked about really was trying to get the ducts located inside the building envelope. So these are various techniques to do that. None of them are particularly complicated. A couple of them are a little expensive, but all of them are done reasonably easy. I'm a big fan of one, just the exposed ductwork that we see here on the left picture. I think especially now that kind of aesthetic is in, especially in more commercial buildings, but even in some residential. And then all the way to the far right, using these kind of fur down ceilings. That's actually something that we used when I first got started in green building. I was in a low income housing program similar to Habitat for Humanity, and
Yep.
we built really high performance homes, and we did fur downs. We used
Yep.
9-foot studs on the first floor, and we just put the ducts in that little fur down space. And it was definitely very inexpensive and easy to do, and obviously helped us keep those ducts inside the conditioned space.
That's a great story, and it really helps to reinforce how you use a design, and the net result is you use a lot less ductwork. You
Mm,
design your registers to throw from the wall out to the middle of the room, and especially now that we have better windows and better insulated and air sealed walls, that we don't have to put a register right in front of a window. That's anachronistic. That's just old. That's because windows used to be terrible, but we don't have to do that anymore. You want to go another level of design. This builder built a truss roof, which was a form of like a scissor truss. They put a hard air barrier here, and they had all this space to essentially hang the ductwork in. Then they put a finished flat ceiling, and then they could just blow loose like cellulose on top of that air barrier that you see here. So great choices. Of course, crawl space or basement foundation, just insulate the walls and condition that space and how your ducts are inside. It's a big player. It's a 15 to 20% impact to not put your ducts in the attic, and it looks at downsizing your equipment. So big benefits to that. Also, other issues with ductwork would be things like, of course, we want to seal ducts carefully with mastic, be they inside or outside. We want the air to get to the rooms. And in terms of returns, we want to make sure there's always a pathway for air to get from the room you put it in back to the blower. And that could be a dedicated return or some sort of return pathway or a jumper duct or so on. And in terms of returns, I just want to go on record as saying we have a chronic problem with undersizing returns. You can never have enough, or you can never have too many return pathways. You can never have a return duct pathway that's too big. And the larger return pathway makes airflow much easier, and it allows you to potentially do better filtration too. So, and then, let's be real. A lot of these problems go away if you look at ductless, and we'll talk more about mini splits in a little bit. So from an insulation standpoint, well, I think if you look at the prescriptive code today, the newest code that's out is the 2018 IECC. And if you don't change what that says, it's actually pretty good. And thank you for laughing there. And by that I mean, I think your exterior wall, and again, it depends on your climate zone, but I think you should shoot for at least an R20, and actually really what we should shoot for is an R20 with a thermal break, so it's even more than that, and we'll talk about that in a second. So here are the prescriptive values for walls, and I think for like climate zone 3 and 4, that's what this is, 1, 2, 3, and 4. I think for climate zone 3 and 4, R20 plus some continuous is a pretty good wall assembly, not bad at all. You can do more, but there is a point where you want to kind of spread your wealth intelligently, and there's definitely a point of diminishing returns. But walls, R20 with a thermal break, I think are pretty decent. And then, like we said, definitely want to insulate foundation walls, so there's some continuous insulation. Whoops. And then there's ways of insulating the foundation walls to allow you to essentially, even if you don't finish out that space like a basement, you still insulate the walls. Now all your ductwork and mechanicals are inside. And Joey, very quickly, this is something I don't claim to be an expert on, but this idea of using materials that can actually, in essence, sequester carbon is something that I think we're going to see more and more of.
Hmm.
You want to add
Yeah.
anything to that?
Oh, I'm no expert in that either. But yeah, certainly see a lot of the new technologies are working on that, which could help in the long term.
And
I
not
would
that, yeah, go ahead. Sorry.
I would say that you're being kind of hard on folks. R20 plus a continuous thermal break is a lot. I mean, I would
A
be
lot.
happy if we just did 13 plus 5.
That would be
And
a
we're
great
looking at
wall.
this kind of chart here. And you'll notice that the energy code kind of favor, I mean, I mean, I'm no engineer, I'm okay at math. 13 plus 5, I believe, is less than 20. So what they're saying is that if you do 13 between the studs and then a 5 continuous insulation, such as this styrofoam here in the middle that we see, then that's about as good as an R20.
It's
So
actually
they
better.
definitely, yeah, they actually, and yeah, we could do the math, and I think we have done the math in
Yep.
one of those previous webinars, in that it would actually perform a little bit better. So do definitely consider continuous insulation. I think that that's an easy one that builders can do. And if the Georgia codes hadn't been amended, you would be required to do it anyway. So I think it's
Yep.
a good practice to get into, especially if you're going to build in other states that have better energy codes.
Or, just again, this is about beating the energy code, and I
Mhm.
definitely think continuous installation is the way to go. I would say in general, there are some really cool products that are not as common in the South, but that are essentially plant-based insulation materials, and just don't have much of a environmental footprint to them. So some nice things to look at there. But again, all insulation is going to do good, and most likely in its lifetime it's going to offset its own carbon footprint. But
Yeah.
certain types of foam board, for example, sadly the blue and pink actual styrofoams
Hmm.
have more of an environmental impact than the polyiso foam, or even the EPS foams. And there's other continuous insulation products like rigid rock wool products too. Those are somewhat, you got to do a little digging on some of this stuff, and probably more than we can cover today. In terms of the actual framing, we're certainly big advocates of trying to put wood where it's going to work for you structurally. You've found this graphic. It kind of shows a, sort of standard framing, and then advanced framing, how you're probably 24 on centers, and you're using, ladder tees and things like that. And there's just all kinds of details you can use to essentially not have a building that's any less strong, but that has a lot less conduction pathways through the framing. This was a house that I think did a nice job, where they framed, it's a 2x6 plate, and it's got
Hmm.
2x4 studs, and
Hmm.
the inner studs are 24-inch on center, and the outer studs are 24-inch on center. So they're staggered by 12, but that allows you to spray insulation inside here, and effectively the only thermal bridging happens is at the bottom plate and the top plates. So that's a really cool way of doing it. And you also notice you can frame in such a way to get insulation back in the corner. And then this, I believe this builder also oversheathed, and this, which is a way of, you can do that in a number of ways. You can wrap the whole building with wood sheathing, and then come back on top of that with continuous insulation sheathing, where you stagger the seams. Or there's a lot of variations on that, but that's probably the most common one. So that's a good wall assembly. There's also products like the Zip system has I think it's called Zip with R, or I don't know, Zip R. That's what I call it.
Hmm.
But it's insulated sheathing. It's a OSB sheathing with an insulated board pre-attached to it, and a weather barrier on the other side. So I like that product. In terms of mechanical systems, what are we looking at trying to do? We want to, well, here's an interesting one. So if you're going to use gas in this day and age, you want to make sure you're using really pretty much the most efficient equipment that's out there. So for gas space heating, you're looking at a 95% AFUE furnace or better. They do have them up in the 98%, which means literally, you know, you buy 10 units of fuel, you're getting 9.5 units of heat into the space. So it's a condensing technology. It's been around forever. It's a no-brainer. It's very safe. It's obviously very efficient. It's the best way to go. And for cooling, you know, the big thing to me, the big feature you want is variable speed. So variable speed kind of has different meanings, but at a very minimum, you want the blower, the air handler blower, to be variable speed. But more and more, we really want to see staged compressor as well, or variable speed compressor. And it's really the technology that's helping to make all this happen is either an ECM motor or just an actual inverter-driven compressor motor. So I'm not an expert on this technology, but the outcome is that your equipment can modulate itself to match the load on the house at that particular hour, which is very important because historically we size equipment for the hottest day of the year, and most of the time it's not. So this allows, anytime your equipment can run on low speed, it uses just a fraction of the energy on high speed. So very important. Obviously, we want to do a load calc. We did a whole webinar about that last time, and it's going to be posted very soon. And then I also like this idea of kicking the tires on the installation, because a lot of HVAC doesn't necessarily get installed correctly. So there are some protocols now, you know, for quality installation. That's something new that the HERS industry is addressing, and there's other forms of that as well. So just commissioning it, making sure it's really working, and also maybe some sensors that are actually sort of taking its pulse during normal operation and are checking it to see if something goes wrong. So that's also kind of clever. Some new stuff on that front. Joey, anything you want to add?
Oh, you gave them an out by allowing them to have gas. I think I'll say that, you know, we don't have to have natural gas in homes anymore. I think
Yeah.
that, I mean, especially down in the South, heat pumps work really well. And the other reasons for gas that we'll talk about in a minute are kind of, I think, overblown as well.
I think that today, especially with the advent of heat pump water heaters, and particularly the efficiencies that mini splits get us, you can and really will be going to all electric in the future. So some people are like, let's get there now. I think that we need to be at the very least thinking about that transition, that, you know, maybe this is a good enough time to go ahead and do, say, a ductless mini split system, or even a ducted mini split system if the aesthetic bothers you. So I absolutely think that conversation is only going to increase. I do think that gas still is going to be around for a while. It's certainly inexpensive, and it's probably still the cheapest operating cost for making heat. But we obviously want to use it intelligently. So for hot water, maybe in the future, Joey, we'll do an entire webinar on this topic. But this is one where we now have these really great choices for both gas and electric. So if you're going to go with gas, we want something that's very safe, and that means we need to up the efficiency. Tankless is very popular today as well. For new construction, I think you can justify gas tankless. Let me be clear, not electric tankless, gas tankless. For homes that are all electric, an electric heat pump water heater is an incredible no-brainer. It is significantly more efficient than electric resistance tank, to the point where it's probably right on par with the cost of hot water. It's probably only slightly more than the cost of hot water with gas. So it's definitely, it's probably almost 2.5, 3 times the efficiency of an electric resistance tank. So heat pump water heaters, really good idea. There's a lot to be said about where you put them. They can be noisy, and they need a certain amount of space. But a great place, where's a good place for a heat pump water heater? The basement. A basement is an excellent place for one there, because one of the things you get is free dehumidification of the air around it. So keeping a basement dry, like this picture, is a good idea. Pipe insulation, pretty much a no-brainer, very low cost, very good benefit to that. Insulate any bit of hot water piping. Compact plumbing design. Try to cluster your hot water using fixtures, relatively close to each other. Try to run your plumbing lines as small a diameter pipe as you can. You really want to minimize the volume of water between the thing that makes it and the thing that uses it. And so the answer is short, straight lines. The answer is small diameter, and cluster the plumbing together. And also in bigger houses, there's nothing wrong with using more than one water heater. And here's my thing, don't put two water heaters side by side down in the basement on a big house. Put them one on the east wing and one on the west wing, that kind of thing. So, use good judgment on this, and appreciate that plumbers are not tuned into this. They don't get this. They understand leaks, but they don't understand, distribution issues. And it's all about, really trying to minimize the volume of water. So that's why we have things like manifold systems. And Joey, tell us about circulating systems, recirculating systems.
Yeah, recirculating systems actually, basically, if you have a water heater that's a far away from the fixture that you use, and it takes a long time for that water to get hot at the tap, a recirculating system will actually just basically flush that cold water that kind of or the
lukewarm.
The formerly hot water that turns cold after a certain time, and kind of just flushes that throughout the system, so that you have basically instant hot water, which can really cut down on your water usage, because typically you run that hot water for a minute or two before it actually warms up. So that can be up to gallons of water wasted every time you turn on the hot water, which is unfortunate.
Yep, absolutely. And so the big thing is, if you're going, and Georgia's plumbing amendment to show that we're trying to save water has a requirement that basically you have to have a recirculating system if it's more than 50 feet of pipe between the water heater and the farthest fixture. So try not to have that, but if you do have to have that, then use an on-demand circulating control, which is not going to run continuously, not going to run on a timer. You want to on demand, so that somebody walks in the bathroom and occupancy sensor says, okay, you want hot water, I'll run the pump for 12 seconds and get hot water there very quickly. In terms of water, good segue, moisture issues, we spent a whole webinar on this topic, which is, shedding liquid water intelligently. And there's all kinds of stuff about foundation drainage, but from a cladding standpoint, I really always want to have a well-defined weather barrier, water resistant barrier, whatever you want to, WRB. And that can be house wrap, that can be felt, that can be a lot of products. It could be the skin of foam sheathing if you seal the seams, it could be this zip system. But then I would like to have some sort of vented space behind my cladding, between my cladding and the water barrier. And so here's examples with furring strips or with these kind of things. And of course, integrate your flashing details. I love that this picture does not have the big red slash through it. So that means it must be good, right?
Yeah, it looks great.
And yeah, and then also, particularly with what we call low load homes, or as we really are insulating better and better and making more airtight, using good windows, we've cut down a lot on the sensible heat that is gained into the home, but we still often have to deal with moisture. So obviously we want to fix bulk moisture issues, but and make sure we do well on the outside. But we've got to just acknowledge we're in a humid climate. So a dedicated dehumidifier, or at the very least, variable speed equipment that can handle and run in a dehumidification mode, I think is absolutely appropriate. So Joey, did you have a poll to pop up here?
I do. So I'm going to launch this poll, make sure everyone's still awake. Hint, hint. So when dealing with moisture in the home, what should your first priority be? So should you replace all your insulation with craft-faced bats, which have a vapor retarder on them? Should you install a ventilating dehumidifier? Should you deal with bulk moisture and the drainage plane? Or should you install polyethylene sheeting on all the walls? So thankfully, no one bid on that one.
That one.
or the
Yeah,
craft
yeah,
face
don't.
bats, it looks like.
Yeah, I think while we're letting people fill in, don't we really do not have a need for vapor barriers slash vapor retarders in our walls and ceilings. We do want plastic under the slab on the floor of a crawl, but we don't need it in our walls and ceilings. So I'm going to go with bulk moisture. What anybody say that? I can't
Yeah,
see the
I think
poll, so
the majority did. About 70% went with the drainage plane. A few went with installing a ventilating dehumidifier, which is a great strategy once you've dealt
yeah,
with that drainage plane. If you don't deal with the drainage plane, what you're going to do is just take in all that bulk moisture and then run that dehumidifier, 10 times longer than it really should be running. And I've
yep.
seen this many times. People will run dehumidifiers in a ventilated crawl space. That's generally not a great idea. And I'm going
I
to
got a
hide
call.
those.
I got a call last week from a HERS student who's a HERS Raider guy in North Carolina, and he was telling me about this home that had, 70% humidity on the top floor, and this was a fairly
Mhm.
new home, probably 3 years old. And I, I I'm like, I suspect, and of course they're running the air conditioner down in the 70s and the high 60s, and I'm like, I the reason that they're running the air conditioner that low is to try to dry it out. So
Mhm.
we talked about, I think it was a bulk moisture issue and possibly infiltration too. Okay, driving on. IAQ, we did 2 webinars about ventilation and IAQ, but the big picture is to try to select materials, and particularly you think more of finishes here, that are intelligent. Salvage materials have a lot of environmental benefit to them. Brand new materials that have recycled content usually are also good for the environment. And then there are certain chemicals that you really don't want, which are sadly more prevalent than they should be. They're called red list chemicals. So absolutely avoid anything with those. So pick, low, no VOC finishes and stuff like that. And of course, we had a whole talk about filters. I really like a thicker, deeper pleated filter that allows you to have a lot of surface area. Um, and of course, you can do a lot to help control bad air and moisture with a tight envelope, but then you need to provide fresh air. And we talked a lot of different strategies on how to do that. Here's some more pictures. We said, there's theoretically 3 ways to do air changes in a home: suck it out, push it in, or do both at the same time. In the humid climates, we would like to either be a balanced or a positive pressure. So these are all examples of balanced or positive pressure. This is balanced. It's a ventilating dehumidifier, arguably the best technology for a home, certainly a good Band-Aid for a home with a moisture problem. Balanced would be like an ERV. This would also be positive pressure, sometimes called central fan integrated supply. The idea, and then we're also going to pull air at the kitchen and bath out. I call that spot ventilation or local ventilation. We've also talked about good smart controls, all kinds of stuff to make sure we're getting fresh air in case there was a pandemic. I'm sorry, did I say that? In case we needed fresh air. We want fresh air in all buildings, tight and even leaky. Plug loads, I think it goes without saying, you should not be walking in your house and see a single light bulb that's not LED. Go ahead and if they're compact fluorescents, we can debate whether or not you should replace it. But anything that's not that, you need to change it today. Don't wait for it to burn out. With appliances, the short answer is pick Energy Star, and then really try to pick a little bit intelligently on that too. That just because it's Energy Star, if it's a ginormous, walk-in freezer that you don't really need, that's an unnecessary load. So try to make good choices about appliances. And then finally, for renewables, that's actually my house, and I'm going to say that, fortunately I had a nice south-facing roof. It did have a little chimney in the way, but to make the home what we call solar ready, it's unbelievably easy. Solar ready is where basically you have a document that says your home has enough structure that you can easily put solar panels on it. And the big benefit of that is just to make permitting easier. My home has 10-12 pitch. 2x4 rafters, 24-inch on center. And they're like, yep, no problem. So I did add some structure under it. I did not have to, but I did add some structure to it. I put some kickers under it. But and also you want to have a piece of conduit or some means to get from your solar panels to your electric meter. And also, I think in this day and age, it probably behooves us to be thinking about where might I want to put storage. Because down the road, I might want to put some batteries. So giving some consideration to where you're going to do all this. That makes it solar ready. You don't have to actually spend any money on actual PV. Although, let me say, this is a very good time to do PV. If anybody's listening and you live in DeKalb County, you should sign up for the Solarize 2.0 because it goes away at the end of the month. It's an unbelievable deal. Joey, pre-tax credit right now, they're already at $2.50 a watt. And that's before the 26% tax credit. So if you're going to do solar, do it this year because the tax credit is going to go down. Very much look into it. Economics are really attractive. And I like this, that, you know, really fancy architecturally wacko roof lines aren't solar friendly. And, you know, plan, you know, this was from a woman I was on the lead faculty with a long time ago. Ann Edminster had a list of, you know, early design checklist, stuff to pay attention to make sure that you're being solar friendly. And so I thought this was a good little checklist. You know, make sure you can get what you need. Joey, do you want to pull up a poll real quick?
Yeah, kind of as we wrap up this top 10, I wanted again kind of make sure everyone's still paying attention. So what should your first priority be when trying to save energy? So should you get a new high efficiency HVAC system? Should you install solar panels? Should you address the building thermal envelope? Or should you install new windows and doors? So it looks like quite a few. I'm gonna just stop it right now because I like this. We are 100% addressed the building thermal envelope. So no one bit on the solar panels. That's kind of what I was getting at there. And I wanted to give Mike a little bit, if you haven't joined the webinars, it's been a kind of a journey on how much Mike has done on his 100-year-old home.
It still has to do.
Yeah, and Mike, I mean, at what point did you look at the solar panels? I mean, was this early, late in the process?
Well, I wanted to be a real early adopter, so I wanted to do this, you know,
Yeah.
8-10 years ago. But you know, so I had a solar fund, a savings thing set aside, but it turned out great. You know, I did it about December of 2016, so you know, about 3.5 years ago is when it really sort of got hooked up. And I took advantage of this great Solarize 1.0 program, which has been very successful all around Georgia, around Atlanta, Savannah, Athens. And if that program comes to you, you should absolutely sign up for a quote. But even not, we are blessed with some very good solar installers. And I know where you're going with this is, yes, you know, I don't know, people get a lot more excited about solar panels than they do about, you know, air sealing, you know, your top plates. So
Yeah.
I appreciate that. It's both, they're both important. And what I think you're trying to say, Joey, is that generally efficiency actually is a better bang for your buck. And it probably is, but solar has become very, very attractive. So I think we can definitely say that. Okay, can we drive on?
Yep.
I want to make a pitch for a great place to get more information. I think Joey and I both are pretty avid readers of greenbuildingadvisor.com. They have sort of the anybody can read articles, and they have the Prime membership, which I think is totally worth it. But these 3 articles, and this was from last month, I think, July 22nd. One was about designing for solar. One was about your insulation's footprint, if you will, and one was about sort of layout in terms of floor plan, which, I mean, just great design articles there. So definitely check them out. And I want to end on this, and I say end, we have some other stuff, but I love this quote. This is from another a friend of mine who was also on lead faculty with me years ago. He said, if you don't have the design, use the resources. So, you know, sometimes you're stuck with what you get on an existing building. If you don't have the resources, I'm not too wealthy. Well, let's have a really good, efficient design. I'm not saying that is, but, and if you don't have either one, you're just not committed. And it's like, you know, so pony up here one way or the other. Either put the time into it or put some money into it, but we can make buildings much more efficient and much more, you know, environmentally less impactful than we have been. So this, I thought that was a great quote. And then in terms of technology, how to kind of get there, we have great tools. We have energy modeling that can help us figure out our target energy use index, which is basically a fancy way of saying how many thousand BTUs per square foot per year is this home using. And so one great website is the Architecture 2030 Challenge, which a few years ago I went and looked at, and it said the site EUI. Source has to do with, you know, what fuels are making your electricity and things like that. So I don't have a lot of control over that. I do have control over my site EUI, which is how much energy is my house using. So a house in the South, single family detached, is about 42 kBTU per square foot per year. And my goal was to hit half of that. And so I think I have it open. Let's see what happens. Yeah, so I kind of religiously track my utility bills because I'm that guy. Just so you know, I am that guy. And I can look at my energy bills for about 20 years, and I can see what I've spent, and I can see how I'm doing, and I can see what happened when solar came in. And if we had more time, I'd show you. This is our electricity usage, and it did a pretty typical kind of peak in the summer, spike in the summer, a little spike in the winter, that kind of thing, until we had kids, and then it went way up. The blue is cost, the dark color is consumption, and you can see this is when utility rates went up by over 50% in about a five-year period. And then also you can see, when did I install solar? Well, you can see the last 3 years, what happened to electricity consumption. So we managed to offset about 93% of our solar. This represents what my home is actually using from the meter, but we offset 93% of that. So with gas, I don't know if I want to show you this similar kind of thing. Maybe I can show it a different graph way here, looking at it. It would help if I knew where I was going. Nope, that's not it. I swear I got it. Oh yeah, this is gas consumption, and you can see, you know, like the first full winter we were in our house was December 2000 to 2001. In January 2001, we used about 573 therms of gas. That's the 7 coldest months. And here it is going on in the future, and you can see with efficiency and improvements, we're getting it to go down. We got it to drop below 200, and that's about where it's been hanging out in the last, I don't know, 8, 9, 10 years or so. And we've added some appliances and stuff like that, but you can see that our gas is about 1/3 of what it was the first year. So where I'm going with this, and then I promise I'll stop. We'll stop looking at graphs to make everyone happy. Was I plotted that, or I was tracking this, and it's pretty easy to take your kilowatt hours annual for the year. And once we had kids, we were typically using about 6,000 a year, maybe a little more, 7,000 in 2010. But I would say around 6,000 kilowatt hours a year. And then also a certain number of therms per year. And you can convert all those into BTUs. And then you can say, okay, take the BTUs divided by the square footage of our house, and you can see our EUI. So our first year EUI was about a 50, and then we got down to about a 40, and then kept getting better and better, getting down into the 30s, and then now we're in the low 20s. So I was able to kind of that was my goal, was to hit my halfway target. I haven't given up, but that was a goal. So I think having data like this is valuable because it helps you sort of push for a goal, and you can model and try different things. Also, when you participate in a Beyond Code program, I think that there's a lot to be said for that. So Joey, that's probably the meat and potatoes of what we wanted to talk about. I think this is all just painful stuff to mention, but I'm just going to say, with LED lighting, there's an incandescent light bulb. 219 kilowatt hours a year. Here's one that's a compact fluorescent, 51. Here's an LED, 33. And the economics of each of those, you know, a 60-watt bulb equivalent is going to cost you $26 a year or $4 a year. You know, so it's really the cost of the bulb is insignificant compared to the cost of the energy it uses. Is that okay? Did I go too fast, or you want to add anything to that? Here's the
No,
slide
I think
about simple payback.
this is, you know, I don't like
I
math.
did a yeah. I did a payback on a 75-watt incandescent bulb replaced with a LED, and I said the LED bulb costs you $3. What's the simple payback on that? And if it's on, in this case, it's on, let's say 10 hours. That's a lot. It's a month. The payback is a month. So LED is going to pay back, even if it's on 1 hour a day, it's still going to pay back in a year. So it's really hard to kind of beat that. I think that's enough said. Can we jump to the end? Is that okay? The rest of this is kind of talking about HERS index and all that good stuff.
Yeah.
And
Yeah,
HERS raters are folks that can help you with this kind of stuff. So got us to the finish line.
Yeah, all right. And if for those of you who don't know, we try to kind of close it or kind of try to wrap up the material at noon, it's Eastern time. And then we like to stay on for 10 or 15 minutes just to answer any questions. I know that we covered a lot of ground today, so basically you can ask us a question about anything, and I think it wouldn't be out of line here. So I'll give you guys a little bit of time to kind of get those questions in. And two, we've kind of hinted at it throughout the webinar today, but this is going to be the last one of these of this webinar series for the foreseeable future. You know, with the believe it or not, holidays are coming up in November and December, and you know, it just didn't make sense to kind of continue it. So we're going to pause it at least through the end of the year, and then maybe pick it back up in 2021. So thank you all for joining us on this this journey that we've been on for 12 webinars. It seems like quite a few of you have been here for most of them, so thanks for that. And then we're still accepting ideas and things, and also we want to get a little bit more formal feedback. So like I said earlier, to either today or tomorrow, Ollie is more likely tomorrow, Ollie's going to send you a survey, and it's going to have a few questions. You can kind of give us more ideas for topics. Let us know what you got from the webinar. You know, if you did any of these changes that we've talked about for the past few months, or anything else you want to tell us. We're going to give you that opportunity here tomorrow or so. So do look out for that email from Ollie and give us any feedback that you have. I have a couple of questions, and I'll give you a chance to kind of wrap things up too if you want.
Yeah, well, I also want to thank everybody for joining us, especially anybody that made it through all 10 or 12 of them. You deserve a medal. It's been a lot of fun for me, Joey. I also want to thank you. You've been a great co-host, and I'm sorry that we kind of have to mothball this for a while, but we have to make some money and stay afloat, hopefully. But please feel free to reach out to us. Email is probably the best way to get a hold of us. And there's our email addresses. Also want to make a plug for these other great resource websites. We're very blessed with some very smart people that have helped educate us and help educate our industry. So let's keep trying to, you know, improve our industry and make it better and improve existing buildings, because that's one of the best things we can do for the environment, and very, very exciting stuff to do, and also very rewarding. So thank you, because I know at least a couple people had let me know that they got inspired and they were going to do some home improvements because we nagged at them, I guess. So we don't have a formal call to action slide this time, but I'm gonna put it out there and say, you know, do something good for yourself, do something good for the planet, go make your home or whatever, wherever you're living, try to make it better. And I know I even helped a colleague. He held his phone and walked around. We walked around his attic, so I could do, you know, remotely. So maybe we should sell that service, Joey, and you know, just walk around people's attics. Anyway, with that said, thanks again, and let's see if we have any comments or questions.
Yeah. Yeah, so toward the beginning, we're talking a little bit about windows, and I think as we went, we kind of talked a little bit more about environmental costs and carbon and whatnot. But someone wanted to know what's the life cycle cost comparison of extruded fiberglass versus wood, considerations for the end of life environmental costs for, I guess, either of those
Yeah,
products.
yeah, I think, and this is totally, so first of all, life cycle assessment is, this is me talking, I kind of see it as, it's sort of like economics, right? There's some definite equations and theories and application of formulas to it, but there's also a bunch of assumptions, right? So it's not,
Mhm.
there's microeconomics, there's macroeconomics, but uh, it's not pure science in the sense of, we have to make assumptions and we make models, and it could probably be similar to, say, pandemic modeling and things like that. But and I would say with life cycle assessment tools, you have to be a little bit wary of whose criteria you're using, because, and I always like to know who paid for the software to be developed, because chances are, if it was, whatever industry it was, the concrete industry, suddenly their product's going to look really good. But because there's a lot of very subjective weighting criteria that comes into play, where you're weighting the energy footprint of manufacturing a product, but you also have to look at the raw materials, where did it come from, shipping it, and some of that, and then you get all done, you go, okay, what's more important? So this, when I say weighting, I mean, is the weighting of, did the people working in the factory get paid a fair wage, or is it, this product is made from natural resources, this is made from petroleum, but the natural resource product doesn't last as long, that kind of thing. So I think everybody gets that it's kind of a big hairy thing when you talk about life cycle. Having said that, we can certainly measure carbon footprint or carbon impact of the manufacture of and shipping of a product. And when you look at that, um, a plant-based product stacks up really well. So wood looks really good in that. What's the downside of wood? If it's not maintained, or if it has poor flashing details or whatever else, and it rots out, that's a problem. Wood, vinyl, and extruded fiberglass all have about the same uh, um, thermal performance. That's what I want to say. So in other words, from an insulation standpoint, they're all pretty comparable, and they're all decent. They're much better than a metal frame. And of course we had metal frame with thermal break, and so we don't see those much in houses anymore. So vinyl, to be fair to that industry, vinyl windows originally were kind of cheap, and they had a lot of problems. The standard window today is vinyl, and it's a pretty darn good window. And a lot of the durability aspects of vinyl windows have been resolved. I mean, I think you got to be fair to that industry. But vinyl has toxicity issues in its manufacture. It is petroleum based, and so I would say that's going to hurt it. I think I'm down to extruded fiberglass or wood. Extruded fiberglass is made of glass. Glass, the raw material is sand. We ain't going to run out of sand. It is definitely more energy intensive in its manufacture, but it also offers a lot of good durability aspects. It has kind of all the good of wood and vinyl without the negatives of wood and vinyl. So I'm kind of torn on those two. I think if I'm purely looking at durability, I think you can, or looking strongly at durability, I think you can make a strong case for extruded fiberglass. If you're looking more at the footprint, I think wood is going to stack up better. But that's a great question. Joey, what do you want to add on that?
Oh, I think we covered it. We kind of touched on a little bit, but keep in mind too, the U factor is not insignificant. And while we in the new construction have gotten away from metal windows, there's still quite a few out there. And so keep that in mind that that conduction through that frame is pretty significant.
It's a factor. Yeah. I think the next big step in Windows, because double pane low E, was that was the goal, to get people to use that back when I started at Southface. Today, that's the standard window. To me, probably the next big leap in technology is going to be some form of additional films in there. And
Yeah.
by films, I mean like effectively a triple pane window, but probably the middle pane is actually a very thin, layer of something. I don't know. But our windows today are a little better than R3. And when we get a triple pane with low E coatings and a good frame, we're getting, we're starting to get closer to R5. And those
Yeah.
windows exist. They do exist. It's just they're very, very expensive. So,
Yeah, and there's a couple ways to go too. We talk about it more in commercial with like electrochromic glass and glazing,
yep.
but you can also go backwards in technology. Solar screens and solar films that you put on the outside can be effective, and kind of gives you that same effect as a solar screen is like basically a bug screen, but the screen material is made out of something that offers some UV protection, so
Yeah,
that
thicker weave, right. Yeah.
yeah, and you can actually use those similar to this orientation where you put those on in the summer, and that blocks a lot of that solar heat gain, and then you take them off in the winter, and it kind of lets those. So that's kind of a
Yep.
retrofit. But maybe you wouldn't use that on new construction, or you wouldn't design around it anyway. You might be able to add it later, but
It's a
something to
technology that really works. It's also kind of cool because if you're inside looking out, you can see quite well. But if you're
yeah,
outside looking
it
in,
doesn't change
it's a
anything.
privacy thing.
Yeah, we use
Be
those
a
a lot.
little wary. I do want to say be a little wary of adding a tint to a double pane window
Mhm.
because some tints can void the warranty. If it's an old window, who cares? But it can sort of mess with the thermal performance of that window, which could cause seal failure. So just be a little bit
Hmm.
wary of that. But I agree. I mean, I'm not scared of it, but it is something that, check with your manufacturer's warranty on that.
And
Great
then we can
question.
go even a little bit further back in the technology and use tree shading. I mean, I know we like to knock
Yeah,
down all our trees when we build
yeah,
houses, but
that's a
can
really
be
good point.
helpful
That
as
should have
well.
made my top 10 list is be nice to the site. Yeah, I,
Yeah,
I agree. We could do a lot more on site issues. And again, that's where going to some of the beyond code programs, might really be appropriate there. I don't know where that was. I'm just guessing where that slide would be. The beyond code programs, where are those? But yeah, I do think that those can help you with some of those site issues too, for sure, for
mhm.
sure.
Yeah, and if it wasn't clear, I was stalling a little bit. We didn't get a lot of questions in, so I'm going to give you guys just like one more minute before we shut this thing down.
Time
So
to go eat
last
lunch.
call for questions. Yeah, you know Mike has to get to lunch, so
Never missed a meal. Thank you again, Joey. Thanks everybody for participating, and really been a lot of fun to to do these webinars, to be a part of these, and hopefully we'll get to come back and do some more. So thanks for supporting Southface, for everybody that does that too, and please check out our website for good resources. Anything
all
else?
right, nothing for
Thanks,
me.
buddy. Pleasure, Joey.
All right,
Thanks, buddy.
see ya.